Alright, let's have a look at how to solve linear system of equations. I have two equations and I need to solve them, and that means I need to find where they intersect. And as we said before, that there are three cases. First case is that they intersect at one point, and that means you have only one solution, or they meet at no point. That means the two lines are parallel. That means they have no solution whatsoever, because as parallel lines they never cross each other out. And the last reason, we have infinite number of solutions where the two lines lie on each other. They have the same slope, they are parallel, at the same time they have the same y-intercept, so they actually on each other. They have infinite number of solutions. Then we have a look at this question. I have two equations. The first one is 4x minus 3y equal 10, and the second one is 9x minus 2y equal to 6. So there are many ways to solve these two systems. The first way that come in mind is like substitution. So we solve, for example, the first equation for y, and then take that value and replace y in the second equation by that value. But the easiest way, I think, is if you can actually multiply by a certain number and eliminate one of the variables. That gives you an opportunity to solve it faster. So if I think about it, the y in the first equation is multiplied by minus 3, and y in the second equation is multiplied by minus 2. So if I actually do a cross and multiply the first equation by 2 and the second equation by 3, I will have the same coefficient for y. So I will end up with these two equations. So I have 2 times 4 is 8x minus 6y equals minus 20, multiplying the whole equation by 2. And the second one, and the second equation, we're going to be 27x minus 6y equals 80. And as you can see, I have the same coefficient, minus 6, for both equations. They have the same number, they are the same sign though, so you need to subtract the two equations. So I'm going to subtract by replacing all the signs, swapping all the signs like that, and then minus 6 plus 6 becomes 0, they cancel each other out. 8 minus 27x becomes minus 19x equals minus 20 plus, minus 20 minus 19 is minus 38. Go ahead and divide both sides by minus 19. You end up with x equals to positive 2. But you need to solve for y, so replacing 2 in any of the equations actually. So I'm going to choose the easiest one. I'm going to replace it in the second equation. So I'm going to end up with 9 times 2 minus 2y equals 6. So that gives me minus 2y equals minus 12. Then we divide both by minus 2, cancel out, then y becomes a 6. So the solution, I have only one solution, which is at 2 and 6. And as you can see in the graph, if you graph them, I already did this previous to this video on Dismos, and you're gonna get the intersection point at 2, at 2 and 6, which is the answer.